Good morning, good evening, good afternoon, good day, wherever and whenever you are consuming this little side asynchronous bit of suggestions that I have for you. I wanted to talk to you at the start of the term about some suggestions that I have for how to study for the weekly case studies and for the lecture final. When you've got a zero point 0.5 credit at the University of Guelph, it's designed to have 10 to 12 hours of work in that class per week. So with your labs and lectures, you've got 6 of those hours taken care of. So that leaves 4 to 6 other hours where there is constructive and meaningful engagement. And so some of the suggestions that I'm going to make here would fall into that meaningful engagement that prepares you for these necessary evaluations. So most of you have taken 2700 and you've seen these kinds of evaluations before. So I wanted to talk about the fact that you are not going to be asked to memorize things. That's not the point. Memorizing, remembering, recalling. If you've seen this triangle is called the Bloom's taxonomy or hierarchy of learning. These are the lower kind of entry level. This is a stage of learning, but it's a stage that by your third year, by your upper year in university, we would expect you to be moving past and independently through. So the actual evaluations are going to ask you, as the learning outcomes say in each lecture, to appraise, synthesize, and interpret new information that's informed by the experiences, by the taxa and the phenomena that you've been introduced to in the lecture. These then, appraising, synthesizing, and interpreting, these are the higher level learning outcomes, or the higher level, more engaged and active verbs, and the higher level skills that you're going to carry with you, whether you work as a biologist, an invertebrate biologist, as a reporter, as a lawyer, whatever. These are the most transferable higher level skills that these case studies and the exam have actively been designed to help you with. And that's one other thing that I wanted to mention, is that the final lecture exam follows the same format as the weekly case studies. So by going through the act of preparing and writing these, you are essentially practicing. So you are preparing and studying for the final by keeping up with these weekly events. Now, how are you preparing? How have you prepared for examinations, evaluations in the past? And I'm going to get that a lot of you guess that a lot of you in the past have been told to read over your notes, distill your notes, rewrite them, get them down into smaller and smaller, more brief and concise bullets, and then look at them and study them and memorize them. And that's a great start. That is a useful start, and it has, I think, for many people, it has a role. What that stage is, the distillation and the reviewing, it's not a great finish. That, if it was your finish, that keeps you at the entry level, at the base of that Bloom's taxonomy. And you want, in your career and in your learning and in your education, to be taking advantage of the higher levels of that pyramid. So how do you go further than that? You make more active steps. And one of the most powerful active steps that you can make is to write your own questions. This is literally the act of, by constructing the questions, by going into the literature, by using the lecture outlines and the lecture learning outcomes that will be associated with each week's lectures, you can literally, you're going through the act of appraising, synthesizing, and interpreting. And so you're living those actual learning outcomes and taking advantage and putting yourself in the higher parts of that Bloom's taxonomy. So these are some of my suggestions now. Use the outline slide. Here's a couple from, I think, the third lecture which was about the third lecture in the class and our second day talking about plankton. Thinking about the outline, which in brief bullet form will tell you kind of about, in broad brushstrokes, where we're going. And then the learning objectives lets you place those broad objectives in for the lecture in the larger objectives of the course. Now those will give you terms, taxa, themes, phenomena that you can then turn into searches. into Google Scholar or Google Image to get you other examples. And then once you've got these examples, once you've seen some graphs or some maps or some phylogenies, those kinds of things, you can start writing your own multiple choice or multi-select questions. And this is a very powerful approach because, and you can make it even more powerful by grouping together. Make a group, a small group. Probably bigger than 5 is maybe hard to manage, but 3 to 4 is kind of ideal, because if you each kind of pinky promise to, for each lecture, that you're each going to come up with 3 to 4 questions for the others. If in a group of 3 to 4 with 3 to 4 questions, that gives you a bank of preparation, of study, of actively considered higher level Bloom's taxonomy verbs, bank of questions for you to consider and to study with and to prepare for. So 3 or 4 of those you're making, and 8 to 9 of those you're receiving from the others in your group. And that extends, the value of that extends to the final, because if you then in your group kind of agree to come up with 1 or 2 questions per lecture shared amongst that larger study group, that gets you into a much more actively and engaged set of scholarship that takes you beyond simply memorizing examples. So that's me telling you, let's show you, let's go through an example. Let's say we talked about plankton. Let's say you were going to go in to the interpipes, and you were going to look for krill abundance. So you look around, and some of them are just images, but then you see some drawings, and you're like, okay, well, here's a science article that looks like it has some kind of a trend line with some sampling, so it's got a map. There's lots of kind of thoughtful fodder for questions there that actively engage you at this higher level. So let's click on that, and okay, so we'll take that question. Let's take that one. So that was here. And let's say you can come up with some kind of a multiple choice question, right? Where you extract 1 element or 2 elements, 3 elements, however you want to do it, and you write for yourself a question about, so for instance, thinking about the others in your group, you could say, consider what is plotted on the y-axis as krill abundance here over 30 years. And the y-axis indicates a change in abundance. So a 0 is no change from the average. The positive numbers are an increase from the average, and a negative number is a decrease. So informed by your experiences with plankton and the information in that figure, come up with answers to these questions. And so pretty quickly, you're going to have to start to, if you give yourself, say, write 3 positive statements about it, 3 true statements, 3 statements that are supported by the data that you're seeing. So that's what I've done here. So that's the T and the F. Krill abundance varies through time. Clearly, it goes up and down. The variation in krill abundance appears to vary cyclically through time. And as you read these things, one of the other elements that I can tell you, read them out loud, because your eyes will lie to you and say, yeah, we're done, move on. But if you hear them read out, you're like, oh yeah, I forgot to write in that part. So it varies cyclically. So yes, on a periodicity with 5, maybe 7 years, it looks like there's some peaks and some valleys. Appears to. So we're not saying that definitively, but it appears to. How about this statement? 8 out of 10 of the 2010s, 8 out of 10 of the decade, the 2010s, were at or below average abundance. We'll just count those up and say 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7, 8. At or below the average abundance. So yeah, that then in a plot that initially set you up to think, maybe you looked at it, you glanced and you're like, well, there's not so much of a change through time, and maybe it's just cyclic. But then you look at the actively interpreting the y-axis in the light of the x-axis, and you think, okay, well, that's 80% of the last decade has had lower than average abundance. And so that leads you then to thinking about, well, maybe there is blah, 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 blah. You come up with your final statement that is going to be the false one, that krill abundance is stable through time. So when you give these, when you share these with your group, you of course don't have to share the answers with them don't share the answers with them right away. That takes away the uncomfortable part. And the uncomfortable part is an inherent part of learning. When you are not experiencing discomfort, you are not learning. You're rewarding yourself for revisiting things that you already know. And that's not how you expand. That's not how you become a higher level scholar in university. Let's take a look at another one, another example, which I have over here. And we will say, in addition to Google Image, maybe the place that you intuit you would go to is to Google Scholar, which is great. Diving into the literature, as I've tried to encourage you over the past couple of years, is one of the most rewarding parts about being a scientist, because it literally reinforces the fact that the science is not rules and knowns, it's questions and whittling away at the unknowns. So here we go. This is krill abundance, in quotes, searched in Google Scholar and restricted to just very recent things. So I kind of scroll down and I'm like, I like the look of this one. Seasonal and spatial patterns of adult Antarctic krill at the Antarctic Peninsula, insights from 41 years of data analysis. So that to me looks kind of interesting. So let's take a look at that paper and we think, okay, it's from the marine, blah, blah, blah. We've got the abstract that can help you construct the question later on. If we've got some good visualizations here. So there's the study area. So when we're talking about the peninsula in Antarctica, it's obviously this kind of western arm here that we're talking about. And then we've got chlorophyll done on grids and sampled through time, but in intensity of chlorophyll with a color map, and then an intensity for the same grids for the sea surface temperature. So a biotic variable, an abiotic variable, and let's see if we've got krill abundance or something up there. So we've got 3 different time series for krill. We'll pick one of them, and that's going to be the question. We can synthesize those, and it's pretty easy to do that for yourself, to take and make a composite figure. So you've got chlorophyll, you've got your biotic variable, you've got your abiotic variable, and you've got your krill, about which the question. So let's say the Western Antarctic Peninsula, it has we've got maps here that represent chlorophyll concentration A, surface temperature, mean density for krill along the Western Antarctic Peninsula. So informed by your experiences with plankton and the information in this figure, which of the following statements is not supported? And you can write them: is supported, is not supported. Doesn't really matter. Depends kind of which way your brain goes as to how you think about these things. So you can figure this one out. I can put the answer in the PDF if you want. But basically, this is just a short aside to say these are the skills that you would want out of a university degree. And so I hope that you engage with them, and I really hope that you take the advice to engage with them as a group, because that's a super powerful and rewarding way to do it. To share that discomfort and to help each other through it. Learning's uncomfortable, but you have the tools to accomplish this, and I hope that you enjoy some of the vast diversity of places that these questions take you. So that's it.